Last problem here. Nothing actually new in this problem, just a slightly different way of performing the math and achieving the same answer. So you'll notice that we've got CH and O again, and this time they've split it up into two different experiments. I'm going to ignore the second experiment right now. I'm just not even going to worry about it. I'm going to pretend that it doesn't exist for right now, and we're going to come back to it. Because right now what they're doing is they're telling me that I have a combustion analysis and I've got carbon dioxide and water, and I know what to do for the first part of this experiment in order to get what CH and O are. So I have 1989 for my carbon dioxide, so I'm going to go ahead and start there. 19.89 grams of carbon dioxide times 1 mole of carbon dioxide per 44 grams of carbon dioxide, and then there's 1 mole of carbon for every 1 mole of carbon dioxide. So 1989 divided by 44 gets me about 0.452 moles of carbon. So for my formula here, my carbon, my hydrogen, and my oxygen, I got that my carbon is 452. Okay, it's 452 that's there. Now I'm going to do the same thing with the water. I have 8.14 grams of the water at 1 mole of water per 18 grams of water, and then 2 moles of hydrogen for every 1 mole of water. So that's 8.14 divided by 18 twice. Gets me 0.904 moles of hydrogen. So I can come right up here and I can say that this is hydrogen, 0.904. And now the only thing I'm missing is the oxygen. So the oxygen is going to come by subtractifying out the carbon and the hydrogen. So I'm going to take this to the next step. I'm going to multiply that by 12 grams per 1 mole. So 0.452 times 12 gets me 5.42 grams of carbon, and this stuff weighs 1. So that's 0.904 grams of hydrogen. So what did they tell us? They told us that the experiment contained 8.74 grams of my compound. So I'm going to come down here, I'm going to say 8.74 grams of CHO minus the 5.42. So this is minus 5.42 grams of carbon, and then 0.904 minus 0.904 grams of hydrogen. So 874 minus 5.42 and minus 0.904 gets me 2.416 grams of oxygen. Now we're going to multiply that by 1 mole of oxygen per 16 grams of oxygen. So we're dividing by 16, and we end up with 0.151 moles of oxygen. So this guy here can go all the way back up, up here. So this is now 0.151. So now that I have that, remember I divide by the smallest of the numbers, so I'm going to end up dividing by the 151. It's almost always the oxygen that you're dividing by in these problems, the way that they're usually arranged. So it looks like it's like a 3, a 6, and a 1 maybe. 0.452 divided by 0.151 gets me 2.99. Yep, that's 3. And then the hydrogen is 0.904 divided by 0.151. That's 599. Yeah, that's 6. And then 1 for the oxygen. But remember, that's the empirical. That might not be the actual formula. It might be, but it might not be. We're not sure what the actual formula is. We're going to need to know more information about this. So this is C3H6O1, but again, it could be C6H9O2. It could be C9H12O3. It could be C12 H15O4. It could be any one of those things, right? And so on and so forth. Well, how are we supposed to know? Well, remember part 2 that we ignored? Part 2 is a gas laws problem. In part 2, we vaporize the substance and then we collect it and we check it out. And it looks like I've got grams, liters, pressure, and temperature. Boy, that certainly sounds familiar. Remember that we have PV equals nRT from our previous parts. And then we've got PV is equal to the grams per the molecular weight RT. There we go. There it is. So that means that the molecular weight is going to be GRT over PV. And I have all of those things. They gave me GRT, P, and V. All I have to do is plug them in. So they told me in the second experiment that it was 3.27 grams. So I'm going to come down here. I'm going to put in 3.27 grams. R is variable depending on what units you're using. It looks like we're using millimeters, so that would be the 6236. So 6236 for the R. Temperature is 220, so that's 220 plus 273 is 493. Looks like that's 493 Kelvin. So I'm going to come down here and I'm going to put in 493 Kelvin. And then the pressure, what they tell me, it was 730 and in a 1.19 liter vessel. So this is going to be 730 millimeters and then a 1.19 liter vessel over here. So what do I have? 327 at 6236 along with a 493 divided by 730 and divided again by the 1.19 gets me a molar mass, a molecular weight of about 116 grams per mole. So which of these guys weighs 116? Well, let's see. The empirical weighs 3 carbons, 6 hydrogens, and an oxygen, 58. So this one here weighs 58, and I'm just trying to get to 116, so I think it's pretty obvious that it's the second iteration, C6H9O2. So the top one here is your empirical. So that's your empirical, and then this is what it actually is, C6H12O2. I screwed all those up, I'm sorry. So this is C6H12O2. That would be 18, and that would be 24 over here. Sorry, got my multiples wrong. Math is a 4-letter word. All right, so there we go. So all of these simply build on themselves. You take the carbon dioxide and water, and you work your way up to getting more information. And based upon the information that they give you, you can always deduce what it is that you have.